In this warm-up, you are combining like terms. So you are going to look for terms that are the same variable. So 3x, 7x, and negative 9x. Or that are number pieces. All right, so 3 plus 7 is 10. Minus 9 leaves us with 1x. Remember, we don't write the 1 in front, we just write the single x. 2 and negative 3 make negative 1. Negative 1 and 6 make positive 5. Here we can combine our x pieces as well. Remember, this is negative 2, 4, and 1. And your number pieces also. In your book on page 123 and 125, you have a set of matching cards to cut out. So, for example, figure 1 has to be matched with one of these equations, but it doesn't necessarily match with the one that's right next to it. So you're going to cut out these 8 cards, and we're going to use them to glue them into your workbook into the table. And your table looks a little different. It has the first 2 rows on one page of lesson 9 and then the next 2 rows on the second, because it leaves you enough space to put those cards, either tape or glue them in. I'm going to go back to the original paper just so that we can connect which figure goes with which equation. So I see here that this one has a set of supplementary angles, meaning a straight line there. Supplementary angles add up to 180. And so here I see 5x and 7x can be combined to make 12x plus 96 equals 180. So figure 1 and this equation here are going to get paired together, and they are going to go in the spot that says supplementary angles. So glue figure 1 here and the equation card here. Figure 2, we see has a 130-degree angle. X and 4x make 5x minus 10 should equal 130. So figure 2 goes with 5x minus 10 equals 130. And that is angles that are adjacent to each other. So figure 2 gets glued here. And 5x minus 10 equals 130 is glued here. Figure 3 has several angles on a line. We have 7/4 x plus 1/4 x. That makes 8/4. But 8 divided by 4 is the same as 2. So 2x. I have 67 minus 50 would be 17. Plus we have another 13. So we should have 2x plus 30. And this angles on a line adds up to 180. So figure 3 goes with this equation here in the row that says angles on a line. And that must mean figure 4 is going to be a complementary angle. So glue in figure 4 here, and then we'll figure out what equation matches with it. Figure 4 has 3x minus 7 plus 16, and a complementary angle adds up to 90 degrees. You can also see in the corner of this angle that little square indicating a 90-degree angle. If we combine our like terms here, negative 7 and 16 would make a positive 9. So we should look for the equation 3x plus 9 equals 90. Which is this card here. So it should look like that. Now we are going to solve the equation from one of those cards. We said these were angles or supplementary angles. And so we had 5x plus 7x made 12x plus 96. And supplementary angles add up to 180 degrees. Now, if we were using algebra tiles, this would be the long bar piece, and these would be the little square pieces. The goal is to get the two separate types of tiles into different parts of the equation. So we want all of our variables to be on one side of the equal sign, and all of our number pieces to be on the other. So to move this 96 over here to the other side, we have to subtract it. Then 96 minus 96 is 0. The 12x still remains over here. And 180 minus 96 would be 84 of those little square pieces. Once I have my variable tiles and my number tiles on separate sides of the equation, I have to figure out how many would go with each variable. So if we're going to split them up amongst the variables, I am going to divide by 12. 12 divided by 12 gives me a single x, and 84 divided by 12 is 8. No, 7. Okay. So then it says check your solution to the equation. So if we plug this back in, 5 times 7 is 35. 7 times 7 is 49, because it's going to go in the x position. So 7 times 7 is 49. And then we have 49 plus 96 to determine that whole angle. Well, 6 plus 9 is 15. 10 plus 4 is 14. So we have one angle that's 35 and one angle that's 145. If I add those together, I get 180. So that is what I wanted, because it should have been supplementary angles. This one asks, what's the measure of angle DAC? DAC is this one here, and we just said it was 145. DAE is this one here, and it had a measure of 35. And BAE is this one down here. This is a vertical angle with the one above it. Vertical angles are equal in measure, so BAE is also 145 degrees. What do you notice? This one was 35. this one was 145, and this one was 145. So the angles that are across from each other are equal in measure, and we just said that that was because they are vertical angles. We call those vertical angles. So the ones that are across from each other, when you see that little X shape from two lines intersecting, are the same. Here I have a little diagram that can show, no matter where I put this line, the relationship of those sets of angles being the same measure remains the same. Refer to the diagram in problem 2 to determine the sum of the following angle measures. DAC and BAE were both 145, and BAC and DAE were both 35. We talked about how when we combined these two, they made 180. And 180 plus 180 is 360 degrees. So if we go all the way around that X shape, we get 360 degrees. We call these angles at a point. So they share a common vertex in the middle. And if we go all the way around with all of these angles, all of those angles add up to 360 degrees. So here I have a diagram. Going all the way around, we should equal 360. It says describe the relevant angle relationship. These are called angles at a point, and they have a sum of 360 degrees. B asks us to write an equation for the relationship and solve it for x. So I'm going to write my equation here, and then I'm going to solve it for x over there, just because I don't have a ton of room to do both. So I'm combining. I have 3/4 x plus 9 plus 3/4 x plus 9 plus 1/2 x minus 17, and that equals 360. So if I add 3/4 x and 3/4 x, that gives me 6/4 x, plus I still have this one here. And then if I add my number pieces together, 9 plus 9 is 18. 18 plus negative 17, it'd be a positive 1. And all of this equals 360. In order to combine these two, they need to have a common denominator. So if I want to change it into fourths, I have to multiply 2 by 2 to get 4. 1 times 2 is 2. When I combine these, I have 6/4 plus 2/4 is 8/4 x. But 8/4 is the same as 2. So here's my equation, and then in the next part B, I'm going to solve it for x. So again, these are variable pieces. These are little number tiles. And our goal is to get them to the same region. So I need to move this 1 over by subtracting it, because 1 minus 1 is 0. I still have the 2x piece on this side, and 360 minus 1 is 359. Now I have my variable pieces and my number tiles separated, but I have to determine how much each variable would get. So I'm going to divide by 2 to learn about single x. If I divide by 2 over here, I have to divide by 2 here as well. This would be 179.5. Now it says to check your solution to the equation and to determine the measures of ADB, BDC, and ADC. So I know 2 of those angles were the same. ADB and BDC are the same. They're both 3/4 x plus 9. So I'm going to start there and use these tools to help me check my solution. Okay, so I had 3/4 times 179.5 plus 9. If you are typing this into your calculator, you can either change this 3/4 to a decimal, or you could multiply 179.5 by 3 and then divide by that answer by 4 and then add the 9 at the end. So this was 143.625, and that was the angle ADB, ADB as well as BDC. Okay, for the other one we had 1/2 times 179.5 minus 17. So you can do 179.5 times 1 divided by 2 and then subtract the 17 from it. So angle ADC is 72.75. Now to check our work, we are going to add up those 3 angles, and we are hoping to get an answer that says 360. Because if we do get that answer, then we know that we have a correct solution. And it does equal 360, so we have solved it correctly. The diagram shows CF, BE, and AD intersecting at point A. Determine the measures of BAC, DAE, BAF, and CAD. Describe the relevant angle relationships. Well, here I see vertical angles. And then if I can determine what x is, I can plug it into this one to determine what that angle is as well. Write an equation for the angle relationship and solve it for x. So our first one is going to say 8x plus 27 equals 32 because these two angles are equal to each other. So again, we're moving this number piece over, which is 5. And then we divide by the 8. So we get x equals 5/8. We can leave it as a fraction or you can change it to a decimal if you would prefer. Either of these answers will work. Now we need to check our solutions and we need to solve for those 4 angles. So looking at the diagram here, BAC. Let's start there. BAC is 8x plus 27. So angle BAC is 8 times 0.625 plus 27. So 8 times 0.625 plus 27 should come out to 32. I'll actually move that up there. DAE is 68 times x. So 68 times 0.625 is 42.5. Angle BAF. Okay, this one is 32. And here they make a straight line or a straight angle, but it should add up to 180. 180 minus 32 gives us 148. So BAF has to equal 148. Okay, and CAD. CAD is this one here. If we have an angle that's 32, 42.5, and this piece here, those all need to add up to 180. So this is going to say 180 minus 32 minus 42.5, which comes out to 105.5. Please make sure that all of the work for your workbook is filled in and you have those cards glued in the correct locations. Check back here for lesson 10.